This is Module 10, Lesson 2, and it's time to look at balancing chemical equations. We said in the last module, or the last lesson, sorry, that in order to obey the law of conservation of mass, we have to balance equations. I gave you the example last time. If we had H2 plus O2 yields H2O, that according to this, we had 2 atoms of oxygen here became 1, and according to that, we destroyed one somewhere along the way. And we cannot leave it like that. We have to make it balance. So what we're going to do is we're going to put coefficients in front of our formulas so that we can properly balance these chemical equations. So now a couple of things as we go about this that my students sometimes have trouble with. One of the things that we cannot do is we cannot come in here and we cannot just put a subscript here and go, okay, now it's fixed. I have a 2 with this H and a 2 with this O, and now I have 2's with everything over here. Because 2O does not equal HO2. We've learned for quite a while now that these formulas, the numbers that go here, decide what the chemicals are. Over here, this is water, and this is hydrogen peroxide. It's definitely not water. If you had a strong enough version of this, and tried to drink it, you would kill yourself. Whereas this, is not deadly in and of itself to just drink some of it. So we cannot change the subscripts. That is an absolute no-no. And we can't write other things in here. We can't just go, okay, well then we'll add another O. It doesn't work that way. We have to work off of what's given to us, and we're going to have to put multipliers in front of the numbers. Those are the coefficients, like out here in the front, that will basically say, okay, we'll have 2 of this whole group. So let's look at how to do this. I've picked several different examples based on the situations that they would give us. Some are easier than others. It basically starts easier and kind of gets harder as it goes. The method that we're going to use is called trial and error. But there are some methods to trial and error. Here is my recommendation as to how to get started. And if you find you can do this in your head after a while, then you don't need to go to the trouble of doing all of these particular things. So I first recommend making yourself a T-chart. And I put my T-chart kind of underneath the arrow because what we're going to do is compare the things that are on the left-hand side to the things that are on the right-hand side. And then I'm going to make a list of what I have. My first element is Si. The next element that I have is O. Then I have H. And lastly, I have F. Okay, it should be the same on the other side. Si, there's my O, there's my H, and there's my F. Okay, now what I'm going to do is I'm going to count how many of each atom are on each side. So on the left side, I have 1 Si. And how I know that is that there's an 1 subscript right there. There's 1 on the right. Well, that's good. That means the Si's are balanced. Oh, there's 2 O's on the left right here, but there's only 1 on the right. That is not good in terms of balance. So what that tells me already is this equation is not balanced. There's 1 H on the left and 2 H's on the right. There's 1 F on the left and there's 4 F's on the right. So now what do we do? Well, we're going to have to multiply. For example, this O right here, I have 2 of them. Well, I only have 1 on the other side, and it is possible to make myself have 2 O's if I multiply this whole thing by 2. What putting the 2 in front of it means is that I have H2O and then I have H2O again. I have 1 unit of another unit, and if there's 1 in this group and 1 in this group, that gives me a total of 2. So we're going to multiply up here by 2, and what that does is it gives me 2 O's. But you have to follow it through. That 2 also multiplies the H's. See, when I had 2 of those, now I have 2 in this group and 2 in this group. That's 4. That's 2 times 2 is 4. So I'm going to find my H's. I'm going to change that to 4. Okay? What made one problem better and one problem maybe a little bit worse. So what we do from there is we pick one of these 2 to do. So I'm just going to choose the H. I have 1 H on the left and 4 H's on the right. I need to try to get 4 over here. Well, as long as there's 1, I can multiply 1 by anything. So if I put a 4 in front of this, that means I'll have HF, 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 and HF. Look, that's 4 of those and 4 of those. That becomes a 4, and that becomes a 4. And look, these are equal, the O's are equal, and the SI's are equal. So our final answer that we would write down for a test, if I take away all of my lines underneath things and clean this up, would be SiO2 plus 4H4 yields Si4 plus 2H2O. Technically speaking, like, it's not proper, like we don't put the ones in front of these, it's just an understood one that's there in front of it. So we just balanced this equation. Let's do another one. What about this one? Okay, my first step, if you can do it in your head, pin a rose on your nose, I'm glad for you. Then you're welcome to try these yourself. If you already are like, I've got this, or you remember it from middle school, or you took physical science and you can remember doing this, then it's not necessary for you to stay with me the whole way. Okay, and I'm going to keep explaining it in depth for people who are like, I'm not sure I get this, please continue. And if you're in the know, then you could just skip ahead to the next one. Pause it, see if you can get it, and move on. Okay, we're going to list our elements. We have zinc, we have hydrogen, and we have chlorine. Okay, there's 1 zinc on the left, 1 zinc on the right, 1 H on the left, 2 H's on the right, 1 Cl, and 2 Cl. So very clearly, this is not balanced. Both of these need to be multiplied by 2. These over here need to get multiplied by 2. So what I'm going to do is find where this H is, it's right here, and multiply it by 2. Put the 2 in front of it. Remember, you can't change subscripts. That gives me 2 of those H's. But it also gives me 2 of the Cl's. So that becomes a 2. And look, this one was really simple. These are balanced. H's are 2 and 2. Chlorines are 2 and 2. I'm done. Like, that's it. That's all there is to this. And again, if you can do it in your head, it's not necessary to show all of the work. They are going to get harder. Okay, so what about this one? Okay, well, let's make our little chart. We have potassium, we have nitrogen, and we have oxygen. There's 1 potassium on each side. There's 1 N on the left. There's 1 N on the right. So far, so good. There's 3 O's right here. And over here, now here's what I'm going to recommend this time. I recommend that you split them up when you do this, like this, so that you can see whenever you do it that they're not together. So I like to do 2 plus 2. If you want to write 4 over here, that's fine. But sometimes I get confused and think that, oh, I can just multiply one thing when they're separate. Okay. Well, what in the world do I do with this? Well, okay. I'm just kind of thinking out loud. This is where it's called trial and error. If I multiply this one by 2, that's going to give me 4 right here. And then this equals 6. I can make this equal 6. I can make 3 equal 6. If I multiply 3 by 2, that would equal 6. So 2 times 3 is 6. But it also changes these. It makes 2 potassiums. It makes 2 nitrogens. And that kind of upsets that. But like, my O's are now equal. 2 plus 4 is 6. But now I have to make these 2 equal. And I can make 2 K's and 2 N's right here by putting a 2 in front. That becomes 2. That becomes 2. But it also changes this O and makes it become a 4. So now that's 8. Well, if you think about it for just a minute, I mean, it's kind of like a puzzle. If I took that 2 away and I could turn this back into 2, look at what that equals. That still equals 6. I just didn't need to multiply it in the first place. 2 K's and 2 K's, 2 N's and 2 N's, 6 O's. Right here's 4 O's plus 2 is 6. That is now equal. It's harder when they're split up like that. Okay, here's my next example. The reason that I chose this one is because something I want to show you out of this one. Whenever you have polyatomic ions, remember the parentheses go on this polyatomic ion. Here's another polyatomic ion. Here's that same one. Here's NO3 again. Whenever you have polyatomic ions, in my opinion, the easiest way to make your T-chart is to keep the polyatomic ions together. I see NO3 together right here, and NO3 is still together over here. OH is together right here. OH is still together right here. So here's how I'm going to make my T-chart. Al, I'm going to put NO3. NO3 is a group of things. A and OH. You do not have to do it this way. However, I do think that it makes life easier. So if you want to list them out and go Al, N, O, Na, you have to make sure that right here you don't list the O again because you already have it one time. And that's going to be a lot of O's. Like, you're really going to kind of make yourself crazy. Okay, so let's count up. There's one aluminum and one aluminum. There are 3 NO3s because if you draw this out, that is Al with one NO3, another NO3, another NO3. And this is where we're really drawing on all of the information that we've had all along. How it has this formula was because it has a +3 charge, and each of these NO3s is a negative. It took 3 of these to cancel that out. There are 3 of them. Well, over here, there's no parentheses. So what that means is that there's only, there's only one. There's one Na, and there's one Na. There's one OH right here. There's no parentheses and no number outside of it. But here, there are 3 of them. So my ALs are balanced. My NAs are balanced. And that's about it. So we're just going to pick one of these. You can pick either one you want to. The first thing that I'm going to try to do is I'm going to work with this one first. I'm going to try to make 3 NO3s on this side. I need 3 on the right-hand side of my T-chart. So find the NO3 on the right-hand side, which is here, and I need to multiply it by 3. You cannot change the formula. So the 3 has to go in the front, okay? That will make NaNO3 one time, 2 times, 3 times. Here's 1, 2, 3 NO3s. That's now 3. That also makes 1, 2, 3 NAs. Made one thing better and one thing worse. So let's just fix the NAs next. Since we just changed it, I need to make 3 on the left-hand side. This needs to become a 3. It's on the left-hand side. So here's the Na on the left-hand side. Put a 3 in the front. Well, then that becomes 3. But it also makes 3 of these. We'll fix 2 problems at once. Now I have 1 and 1, 3, 3, 3, 3, 3, 3. This is now balanced, okay? I can get rid of all my little lines here just to show you what cleaned up it looks like. This will be our final version right there. Excuse me. So 1 AlNO33 plus 3 NaOH yields AlOH3 plus 3 NaNO3. If you don't say a number in the front, it's an assumed 1. Okay, so when you have polyatomic ions, my suggestion to you is if they stay together on both sides, keep them together. Okay, let me show you with this one. This right here is a polyatomic ion, but look what happened over here. It did not stay together. This is not NO3, it's NO2. So in this case, I did not keep them together because it wasn't the same on both sides. Here, it was identical both sides, NO3, NO3, OH, OH. Okay, what about this one? Same thing. I see polyatomic ions. Here's one, ClO3. Does it stay together on the side? Yes, it does. Same numbers and everything. Here's SO4. Here's SO4. They stayed together too, so we're going to try this again. K is our first element. ClO3 is next. Mg and SO4. And all I know to tell you is if you're listening to this and you're going, I don't know how she knows that's a polyatomic ion, is that you need to ask me something, please. Okay, there's 1 K on the left. There's 2 Ks on the right. There's 1 ClO3 right here on the left because there's no parentheses. But there are 2 over here on the right. There's 1 Mg and 1 Mg, 1 SO4 and 1 SO4. So Pick one of these two that you want to fix first. I'm going to go with the K. I need to make 2 of them on the left-hand side. So here's the K on the left. I'm going to put a 2 in front. That becomes a 2. But everything else that's with it also gets multiplied by 2. So that's also 2 ClO3s. And look at that. I'm balanced. 2, 2, 2, 2, 1, 1, 1, 1. Like, ta-da! There we go. Perfect. Okay. What about this one? Okay, the reason that I chose this one is it doesn't involve polyatomic ions, but it involves something that is split up. So N, H, and O. I do not need to list them again. I have N, there's the O, there's the H. There's 1 N on the left, 1 N on the right. 3 H's on the left and 2 on the right. 2 oxygens, and then 1 plus 1. So technically the oxygens are balanced. So here's my advice. When you have something like this that's split up, if it wasn't even, I would always, always, always save it until last. Because it's the hardest thing to balance. And lots of times, if you'll fix the other stuff, it'll take care of itself. Now, in this case, the O's happen to be balanced. So we're going to fix the H's. Well, look, I don't have one of them being a 1 this time. So it's not like I can multiply this side by something that will just magically equal 3. So shoot for a common denominator. A common multiple. A common multiple of 3 and 2 is 6. So I'm going to try to make 6 on this side and 6 on this side. So find the H's on the left side, they're right here, and make them equal 6. Well, 3 times 2 is 6. So that'll be 2 N's, and it'll make 6 H's. Now find the H's on the right side. I have 2. I need to make it equal 6. So I need to put a 3 in front of that. That'll make that 6 H's, but it also makes 3 O's. Now, that's this side, so that's just 3. Okay. Now what do we do? Well, now I'm in the pickle of I have 2 things that aren't balanced. This isn't balanced, and this isn't balanced. Which ones I would handle first? The first thing that I would fix is the thing that's not split up. I would fix the N's first. Can I make 1 equal 2? Sure I can by multiplying by 2. So right here's that N. We're going to multiply by 2. That becomes 2. But it also changes that O to make 2. So now I have 2 N's on both sides, 6 H's on both sides, and then I have 2 oxygens on the left and a grand total of 5 on the right because 2 plus 3 is 5. What in the world do I do? Well, I have another trick for you, and that trick is called the half trick, okay? Sounds kind of crazy, but what I recommend is that you multiply the side that needs to go up by, like the idea is I can't multiply 2. 2 times something equals 5. That's what we're thinking in our heads. Well, you saw that 5 halves. Well, the problem with this is that I can't put 2.5 up here as a coefficient because I cannot have 2.5 oxygen molecules. I either have a molecule or I don't. But you can put it up here temporarily, and you can use it to help you balance. Like if I multiplied 2 by 2.5, this would equal 5. So I'd have 5 oxygens on the left, and I have 5 oxygens on the right. So what do I do to fix it? It's kind of like the empirical formula stuff. What I do next is I need to get rid of the 2.5, I need to multiply it by 2. If I double it, then it'll become 5. But what you do to one coefficient, you need to do to every single one of them. So if I multiply this one by 2, then this one needs to become 4. 2 times 2 is 4. That needs to be a 4, and that needs to be 6. I multiplied everything by 2. So 4, 5, 4, and 6. Now, what we can do is we could see if this works. That's 4 nitrogens, 12 hydrogens, 6 times 2 is 12 hydrogens. So far it's working. 10 oxygens. Well, there's 4 oxygens right here plus 6 over there. Yep, that's 10 and 10. So it is balanced. Okay, so this is exactly what we should come up with. Now I'm going to do this half trick quite a few more times. Okay, a lot of places where you'll see the half trick is on these. It's combustion reactions. Okay, so let's make a list for this one. We have C, H, and O. There's 4 carbons and 1, 10 hydrogens and 2, 2 oxygens and 2 plus 1. Okay, not one thing is balanced. Everything is wrong. So where do you start? You start anywhere but with the O's. I would start with probably the C's and then just march my way down through this. So can I make one C become 4? Yep, put a 4 in front. That's 4 H's, or sorry, 4 C's, but that also turns that into 8 O's right there. Okay, now what? Let's do the H's. Well, can I make 2 become 10? You're always wanting to make the smaller one become a larger one. Sure, I can. If I multiply this by 5, then that will be 10 H's equaling 10 H's, but it also makes that O become 5. So right now what I have is I have 2 oxygens on the left, I have 13 on the right. Like those don't equal each other. So the easiest way to do this is to use the half trick, like we just did in the last one. 2 times what is 13? Well, that would be 2 times either 13 over 2. You could put 6.5 over 2 equals, either way. If I do that, then that makes that become 13. 4, 4, 10, 13, 13. Can we leave it as a half? Nope. So what we need to do is double everything, not just the one thing, double it all. So there's an understood 1 here, that'll become a 2. This will become 13. 4 becomes 8, and 5 becomes 10. So this one is balanced with 2, 13, 8, and 10. Okay, let's try another one. Again, we have C, H, and O. There's 6 to 1, 14 H's on the left and 2 on the right, 2 O's, and then 2 plus 1. Same advice I just gave you. Start with the easy stuff. Start with the C's. Start with stuff that's not split up. Okay, so I'm gonna put a 6 here because that'll give me 6 C's, but it also gives me 12 O's. Okay, I can turn 2 hydrogens into 14 if I multiply by 7. So that's 14, but then this becomes 7. Okay, those are balanced. This is not. 2 does not equal 19. But I can make 2 equal 19 by putting 9 halves up here because 2 times 19 halves is 19. And then what do? We double everything. So this will become 2. That becomes 19, 12, and 14. 2, 19, 12, and 14. Some of these combustion reactions can get quite high in terms of the coefficients, so don't be afraid if they start to get pretty large. Okay, one last one. What about this one? We still have C, H, and O. We've got 6 C's versus 1, 6 H's versus 2, 2 oxygens versus 2 plus 1. Okay, well, this one looks like it should be easier to fix. We put a 6 in front of that one. That gives me 6 C's, but it also gives me 12 O's right there. Well, I can make 2 hydrogens become 6 if I multiply by 3, but that's also going to make that become 3 oxygens, so that's 15 to 2. Well, if I multiply this by 15 halves, that'll turn that into 15. So now I have 15 equals 15. Great. But I can't leave this as a half, so I need to multiply it all by 2. So that becomes 2, that becomes 15, 12, and 6. So 2, 15, 12, and 6. Now, one thing that I want to mention that hasn't happened to us, that sometimes happens with people, is let's just say that you get this messed up, and through trial and error, let me give you an easier one. you come up with something like 2, 6, 2, 6. Is that balanced? It actually is, and if you think about it, I just doubled everything that was up here. 2 aluminums, 2 aluminums, 2 times 3 would be 6 nitrates, 6 sodiums, 6 sodiums, 6 hydroxides, 2 times 3 is 6 hydroxides. It is balanced, but our coefficients have to be in a lowest whole number ratio. So if you catch yourself doing that, and I see that 2, 6, 2, and 6, they're all divisible by 2, the correct answer is this bottom one. The coefficients are 1, 3, not 2, 6. How they'll give this to you on the final exam is lots of times they'll give you a series of equations and they want to know which one's balanced. And what you have to do is look through them and kind of do the t-chart or do the thinking of which one's balanced. Or sometimes they'll give you answer choices that have coefficients like this. Like A might be 2, 6, 2, 6. B might be 1, 3, 1, 3. C might be 2, 3, 1, 6. And D might be something else. And you pick the series that correctly balance, like the case would be 1, 3, 1, 3. So you most definitely need to be able to balance these. So we've done quite a few examples. Hopefully, if you caught on, you kind of skipped ahead a little bit. It is now time for you to practice. You are using the lesson 1 practice sheet, except this time you are filling your numbers into the blanks. What I did was I put blanks in front of everything, like the first one's this. And so what you're doing is you're putting the numbers in these blanks here. If it's a 1, you don't have to put anything. If you have questions, please ask.